We're going to consider a new class of compounds called organometallics. And they're going to act a lot like the other things that we've dealt with up to this point. They'll have some nuance, but my guess is that they'll fit nicely into your repertoire. So let's look at them. So first of all, the three important ones that we're going to consider are organolithium compounds. Organolithium compounds, you see why that would be called organolithium. This is called organomagnesium, and really it has all that in there. This is a halogen, okay? But we're going to call it organomagnesium, or we're going to call it Grignard. And we're going to talk about organocopper compounds also. And we're going to call these Grignard reagents, all right? So let's talk about let's briefly consider the reactivity of organometallic compounds by looking at this. Look at the increasing electronegativity. If we have a copper, or not a copper, if we have a carbon that's bonded to a lithium, look at the electronegativity difference of that, right? Carbon's here, 2.5. If we have a carbon that's bonded to a magnesium, right? And what about if we have a carbon that's bonded to a copper? Look at that, right? See the difference in electronegativity? This to that difference is 1.5. I'll do that in green. The difference is 1.5. I'm going to do that a different. Let me do that 1.5 again. Get a little bit darker of a marker. Okay. The electronegativity difference is 1.5. Here it's 1.3. Here it's only 0.6, right? Look at that. To 1.9, right? So the difference is only 0.6. So this is much less polar, okay? This is almost, I mean, if 0.5 is our polar, you know, the difference between polar and non-polar difference, this is actually not that polar of a bond. Even though that's a metal, which is kind of a surprise, right? But this is a very polar bond. This is almost ionic, okay? So just keep that in mind. It turns out that copper lithium are going to be the most reactive. No kidding. And the Grignard reagents are going to be the next most reactive, right? And the copper lithium, or the Gilman reagents, are going to be the least reactive. All right, and that's what, I mean, I guess I anticipated this slide a little bit. Went a little too fast. Let's, you see here I've got a Grignard reagent because it's MgBr, right? And the Grignard reagent's pretty reactive, right? Because it's bonded to it's a carbon which is bonded to a magnesium. You see that? There's a carbon right there. It's a methyl group, CH3, right? That's what that is. So this is a pretty reactive, and this is less. So since it's pretty reactive, I should point this out. Since it's pretty reactive, we get two methyls that go on there, right? We describe the mechanism later, much later. But for now, that's pretty reactive, right? So we get two methyl groups that go on there. But if the methyl group is bonded to a copper, which is much less much more electronegative, but the difference is much less, right? Then this is much less reactive. So we have a methyl group here. Actually, I have two, but only one of them is reactive, okay? When I draw this out, I like to draw it like this. And this helps me remember that only one of them goes, okay? But look at that, because it's much less reactive. All right, so this is just an introduction to organometallic compounds. The next two videos we'll talk in more detail about what to expect from these three classes of compounds. Let me just go back and put these in front of your eyes again. We're going to be dealing with organolithium compounds. Whoops, lost my marker. Second here. We're going to be dealing with organolithium compounds, organomagnesium, which we're going to call Grignard, and organocopper, which we're going to call Gilman. All right, we'll get more details on that in the upcoming lectures.